Hello student, today is lecture 7 of periodic properties. We have already discussed about periodic table and different laws of periodic table, and in last lecture we started the trends of physical properties in periodic table. So today we will discuss about the trend of ionic radii and trend of ionization energy in the periodic table. So first we will discuss the trend of ionic radius in the periodic table. The effective distance from the center of the nucleus of ion up to which it has an influence in the ionic bond is known as the ionic radius. We have already discussed that in case of any atom, the electron cloud boundary is not defined for orbital. The electron cloud is scattered, and that's why to calculate the atomic radii we took half of the distance between the atoms, the nucleus of two atoms. Similarly here, to calculate the ionic radius, we usually take combination of cation and anion, and then the radius is taken by the boundary distance of nucleus from the boundary, because if two atoms are attached together, then obviously the electronic cloud is having a particular boundation or a distance. So the distance from center of the nucleus of ion up to which it has an influence in the ionic bond. So like here this anion is having influence up to this point for the ionic bond between R cation, R anion and R cation. So by this way we calculate or we measure the ionic radius. In case of ionic radius, the radius of positive ion, that is cation, is always smaller than that of parent ion. Why it happens? Here some examples of cations are given, and you can see that two different colors are here, one orange and another one is the green color. So here it is very clear that the ions are colored here orange or red, and the outer sphere shows the size of atom. Like lithium atom is having this size 152 and lithium cation is having size of 60. Clear? So here it is very clear that cation is having smaller size than atom. Why this happens? Because in the formation of cation, the atom loses electrons. That means electron removed from that place. If we are talking about the elements which are present in group 1, so in group 1 or in case of alkali metals, when one electron removed from the atom, a complete outer shell is removed, and that's why the size become smaller. Also, when electrons removed from the atom or atomic orbital, obviously the interaction or the attraction between the nucleus and the orbital decreases. So the size of the cation is always smaller than the parent atom. Whereas just opposite happen in case of negative ions, that is anions. The radius of negative ion is always larger than that of parent atom. Why this happens? Because in case of negative ion, the electron come into the orbital, extra electron. So when extra electron goes into the atom, what happened? The size of the orbital increases. If we are talking about ionic radius trend in periodic table, on moving down the group in periodic table, ionic radius increases because new shell is added. Similar as happen in case of atomic radius, because when we are moving down, always number of shell increases. Like in first period only one shell is there, in second period two shell, in third period three shells. So number of shells are increases, due to which the size increases. But when we move from left to right across the period, there is no regular trend observed, because each element in periodic table can either lose or gain electron. If we are talking about the period, like if we are talking about the second period, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine and neon. What happened here? Some elements are having tendency to lose electron, whereas some elements are having tendency to gain electron. So obviously, if element lose electron, the size will decrease. If element gain electron, the size will increase. So that's why on moving from left to right across the period, there is no regular trend is observed. Across period, the ionic radius decreases for metals, because metals are having tendency to lose electron and become cations. So all the metals shows which type of tendency? The size is decreases in case of metals only. But for non-metal, what happened? Ionic radius increases, because these are having tendency to form anions. This is because the number of electron exceeded. When anion is formed, the number of electron exceeded, and this will increase the number of the size of the ion. So overall, when we move down, the number of shells increases, and so the size increases. This trend is similar as in case of atomic radius. But in period, the trend is not regular, because some atoms are having tendency to form cations, whereas some are having tendency to form cations, and sizes depend on that a particular atom will form cation or anion. Next property is ionization potential. Ionization potential is energy required to remove an electron from isolated gaseous atom in its ground state. And when this ionization energy is measured in terms of electron volts, it is known as ionization potential. So both are same. Sometimes students become confused that both are similar or different. So these are the terms which are used for basically for ionization process, and the energy required to ionize a particular atom is known as ionization potential or ionization energy. Here you can see that in this diagram, a nucleus is there, and around that nucleus electrons are present in different orbitals. So the extra energy which is required to remove one electron from its outermost orbital is known as ionization energy. So the energy to remove first electron, outermost electron, is known as first ionization energy. Then after that, energy required to remove second electron is known as second ionization energy, third ionization energy, and so on. So it is basically the energy which is required to electron from orbital of an atom. Obviously some energy is required because the nucleus is having positive charge and all the electrons are held in an atom due to the attraction between the positive nucleus and negative electron. So some energy is required to remove this electron. Clear? Now variation of ionization potential in a period. In general, the ionization potential increases on moving from left to right. And why it happens? Because when we move from left to right, the nuclear charge increases. Because the positive charge increases in the nucleus, so obviously the nuclear charge increases and the atomic size decreases. So if atomic size decreases, nucleus, the distance between nucleus and electron will also decrease, and as nuclear charge is increasing, the interaction between the electron and nucleus increases when we move from left to right in a period. So overall, due to these two reasons, the ionization potential increases on moving from left to right. Exceptions in ionization energies trend in periodic table. So there are some exceptions. This is a graph. This graph is showing here the atomic number is given and the first ionization energy. We are mostly we are considering the first ionization energy because this is the most important. So here you can see that for hydrogen it is between 10 to 15 eV. After that for helium it increases, a sharp increase in case of helium because it is a noble gas, and you all know that noble gases are very stable. They are having a complete octet, so it is very difficult to remove electron from a noble gas. After that, in case of lithium, a sharp decrease is there. Why this decreases? Because in lithium the outermost orbital is having only one electron and it is very easy to remove that electron. That's why the energy is decreases. After that, in case of beryllium it increases. This is for beryllium, this is for boron, carbon, nitrogen, oxygen, fluorine and neon. Clear? So here you can see that these are the two places, beryllium, boron and then nitrogen, oxygen. You can see a slight decrease in ionization energy, whereas we have already whereas I have already told you that on moving from left to right the ionization energy increases and already explained. But these two values are exceptions and you can find in some exceptions in every period. So why this happens? Because beryllium, so after beryllium boron is having lower ionization energy. Similarly at this place after nitrogen oxygen is having lower ionization energy. This is opposite to the trend. So why this happens? The exceptions in ionization energy can be explained with the help of electronic configuration. Here the electronic configuration from lithium to neon given, and you can see that in case of beryllium and boron, beryllium is having 1s2 and 2s2 configuration, whereas boron is having 1s2, 2s2 and 2p1 configuration. So here, as we know that S, in case of S the electron cloud is scattered and it is in spherical shape, and so the electron cloud is more near to the nucleus, whereas in case of boron the last electron is present in p orbital, and in case of p orbital, due to the shape of p orbital the electron cloud is far from the nucleus. So it is very easy to remove one electron from the p orbital, whereas it is quite difficult to remove electron from s orbital, and this s electron is also completely filled. So it is easier to remove last electron in case of boron as compared to the beryllium. Whereas in second case you can see for nitrogen and oxygen, what happened? The nitrogen is having the configuration 1s2, 2s2 and 2p3. Oxygen is having configuration 1s2, 2s2 and 2p4. So here you can see that this 2p is having 3 electrons, and these 3 electrons are present in px, py and pz suborbitals. So each suborbital is having only 1 electron, whereas in case of oxygen the one sub p orbital is having 2 electrons, and both electrons repel each other because they both are present in same orbital. So what happened? It is very easy to remove that extra electron from this p, and this, in case of nitrogen, it is 2p3, that is half filled, and we know that half filled and full filled configurations are stable as compared to the other configuration. That's why it is easy to remove the last electron from the oxygen as compared to the nitrogen. Now, variation of ionization potential in the group. Within a group, there is a gradual decrease in ionization potential in moving from top to bottom. This decrease in ionization potential down a group can be explained in terms of net effect of 3 factors. Clear? So what are these 3 factors? The first factor is increase in nuclear charge. When we move down, what happened? The atomic number increases, number of electron increases, similarly number of proton in the nucleus also increases. So when we move down, the nuclear charge increases. Another thing happened when we move down is increase in atomic size. Atomic size also increases because the number of shells are increasing. And the third thing happened is increase in shielding effect. As the number of shells increases, so the outer electron and nucleus, between these two, number of shells are more, and more the number of shells, more the screening. These two factors, that is increase in atomic size and increase in shielding effect, due to these two factors, it is easy to remove last electron from the orbital of atoms. But in case this one, that is increase in nuclear charge, impart more attraction for the electrons which are present in orbital. But this is only one factor which increase the attraction between the nucleus and electron, but these two factors decrease the attraction between the nucleus and last electron. So these two factors dominate on this one single factor, and due to these two factors, it becomes very easy to remove the electron from the outermost orbital. That's why when we move from top to bottom in a group, a gradual decrease is observed in ionization potential. This is all for today. I hope you enjoyed the lecture. Thank you.